Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing something really important about how to make our API much more resilient and less error prone to failure. And here we're going to be discussing retry policies and circuit breakers. And this means that whenever our API is actually trying to connect to any third-party service, what is the type of implementation that we want to do in order for us to connect? In case this third-party service fail, what can we do? How many times we can retry? What is the best outcome that we can actually utilize in order for us to try to switch between these different third-party services in case of continuous failure, so on and so forth. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Now with that being said, grab your cup of coffee and let's get started. So the first thing that we need to do is basically we need to create our application. And in order for us to do that, we're going to be needing the .NET SDK installed. So just to make sure that it is installed successfully, we're going to put .NET -- version. And we're going to be seeing that I'm running on the latest version, but any version of .NET Core should be fine. And now that's installed, that utilize .NET, new web API. And I'm going to call this API Retry. And we can see it has been created, so let me navigate to this and let open in Visual Studio Code. Perfect. I can see that my application is already here, and let me just open a terminal inside Visual Studio Code. Well, let's just make this a bit bigger. And all I'm going to do is .NET build to make sure everything is running as it should be. Perfect. So once we have our application created, the next thing that we need to do is we need to add some packages that will allow us to implement this retry logic. As well, we're going to be utilizing the REST Sharp API library in order for us to do web API calls, or basically web calls, in order for us to do the retries on them. So let's see how that will work. So first things first is we need to install our first package to .NET add package, and the package name is going to be poly. And the second package we're going to put .NET add package is going to be REST Sharp. Okay, perfect. So now if we go to API retry.cs proj, we'll be able to see that we have these two packages installed, poly as well as REST Sharp. Great. So the next step for us is now we need to implement some logic into our controller in order for us to be able to implement this retry. So there's multiple ways where we can actually add the retry logic and the circuit breaker logic that we need. So it could be injected into the program.cs of the application. We could inject it into the actual controller itself. There's multiple places that we need where we can actually implement this. For the sake of this video, and in order for us to make this as easy as possible, we're going to be basically adding it to our controller. We're going to be seeing how we can configure a retry policy from there. We're going to be seeing how we can actually implement a circuit breaker from there. And then if you're actually interested in actually having this inside a program.cs, please add it in the comments down below, and maybe in the future I'll add a video of how we can implement it there. So inside my controllers, what I'm going to be doing is I'm going to be creating a new file. And this is going to be my new controller. I'm going to just call it my service request controller. I can call it whatever I want. .cs. And here I'm going to put the namespace, and it's going to be basically API retry.controllers. Then I'm going to put public class. It's going to be service requests controller, and it's going to take from controller base, and that should be it. But in order for it to be make it easier, let me copy these and just put them here, fix those references. Okay, perfect. And I think that should be it. And now what I'm going to be doing here is, let's just take this as well. Let's add a logger in case we need it. And so this should be here, and this should be here, and this should be here. Okay, perfect. So Now that I have basically a skeleton of a controller, what I'm going to be doing is I'm going to be creating a single action, and this action is going to be mainly responsible to doing a call for a third-party service. And in this case, I'm going to find a random API online which I can utilize for free, and I'm going to be basically doing these calls for it. And what I'm going to be doing here is I want to mimic type of unavailable services. So for example, inside our application, let's say I'm building a financial application and I need to get the currencies, the latest currency conversion rates. So what I need to do is I need to create within my application, I need somehow to connect to this third-party service in order for me to build those currency information. But what happens if that currency endpoint that I'm utilizing is not available? So what I need to do is I need to implement some kind of a retry logic where basically I'm able to go and check those currency information. If it's running, I will be able to get it. If not, I need to wait for a bit and then retry again. If it's not working, wait for a bit, retry again, so on and so forth. So the first step that I'm going to be doing is I'm just going to basically create a connection to any random API just to make sure that this connection works. I'm able to get the information. The second step is I'm going to be implementing this retry logic to make sure that I'm able to connect in case there's a failure and then basically be able to bring that back. And the third thing is we're going to implement circuit breaker. So we're going to basically retry a couple of times. If it doesn't work, we'll stop connecting for a certain amount of time, and then we'll retry again, and so on and so forth. So these are going to be the 3 steps that we're going to be taking in this video in order for us to understand why do we need poly and why do we need to do these retries. Because in essence, in order for us to make our application resilient, and we need to make it basically as much as possible prone to safe against failures, what we need to do is we need to make sure we are catering for all the different scenarios that we need. So for example, here we can actually implement health checks. If you don't know anything about health checks, I have a video about it where I'll be linking here somewhere where you can actually go and watch it. But basically health checks on top of these retry policies and basically retry structure that we're going to be doing and mechanism, it will help our API to be much more robust and less prone to failure. So let us see how we can first do an API to third parties. So first things first, I'm going to be checking the API which is going to be I'm going to be utilizing to do these calls. Let's see how this looks. Let's make this a bit bigger. Okay, I don't want this. So basically what I'm doing is I'm utilizing Rapid API again, and basically this is an API, it's a free API you can utilize, and it will allow us to basically query an API and get some response back. And in this case, I'm utilizing the Chuck Norris API. It just basically gives you random quotes, funny quotes about Chuck Norris, which is really nice. So inside this API, I'll leave this URL in the comments down in the description down below if you want to utilize it again. So what I'm going to be doing here is basically this is going to be the API that I'm utilizing, and here you can see the different endpoints that are available for me. Here we can see that we have a sample of the actual code that we can utilize, and the nice thing about it, if I go to C# and Rust#, it will give me the exact source code that I can utilize in order for me to do an API call here. And then here we can see the different headers that I can pass on and the different, for example, query string that I can utilize, which is a really nice API to have, and it's also free, so that's really good. So what I'm going to be doing is I'm going to first create the code in order for me to call this API, and once I have this code, I'm going to check it within our action to make sure that it's actually working as it should be, and then we're going to be implementing the retry logic. So let me go back to my Visual Studio Code. And first things first is I need to create my action, and here we're gonna put basically HTTP GET, and I'm just gonna call it, give it a name of get data. Name, I'm gonna call it get data. We can call it whatever we want. Again, it's a simple endpoint that I'm utilizing, and this is gonna be public async task action result, and it's gonna call get data. Actually, just make it get. And here what I'm going to be doing is I'm going to create a new method, and this method is going to be responsible to do the API calls. First of all, let me just return OK. Again, this is all part of sample. This is not how you actually should create your communication with third-party libraries. So I'm just going to create a method. I'm going to call it, make it private, and I'm going to make it return void for the time being, and I'm going to call it connect to API. And basically here what I need to do is I need to utilize the REST Sharp library in order for me to do this third party. And the reason that I utilize REST Sharp, it's a really easy library and it's really powerful one for me to actually call third party services, do all of these API calls. It has a very friendly utilization to adding headers, query string, bodies, uploading files, so on and so forth. And and actually it can be utilized to create it as a injectable service. That's a different topic, but I really like utilizing it and I highly recommend utilizing it as well. So first things first is we need to specify the URL that I'm going to be calling. So I'm going to put var URL equal, and we can, I think, copy paste it from here. So let's go back to my web browser and I can just copy paste this directly. And let's go back here and let me put this here. Okay, perfect. So this is gonna be my URL that I'm gonna be calling, and then the next thing is I need to actually initialize my client via REST Sharp calling. So it's gonna be var client equal new REST Sharp, and it's gonna ask me to actually add those references. So let's add it right now. Okay. Let us do a .NET build. Visual Studio Code usually does not correspond well with C#. I'm not sure why. Okay, let's add this using REST Sharp. Let's see, REST client. Okay, it's my fault. So then once I have created my client, the next step is I need to create my request. So I'm going to put var request equal new request rest request, and then here I'm going to pass the URL and what type of method it is. So basically it's going to be a get. And if I take a look back at the documentation here, and we can see that this is going to be a get request. Perfect. So what I can also do, I just can take these directly and copy paste them here. And I'm gonna update my header and my post host in order for it to work. So I'm just gonna take the key that I have already signed up and gotten before. I'm just gonna copy paste it from my notes. I'm just gonna paste it here. And once I do that, then I'm gonna call to var response equal await client dot execute async, and here all I'm gonna pass is the request. And for that to work, I'm just gonna change this to task. And now that I have a response, all I'm gonna be doing check if response dot is successful. I'm gonna be basically return okay, actually I'm just gonna right now, I'm not gonna return anything. All I'm gonna say console dot write line response dot data. I'm just gonna display or what is it, response dot content. Yep, I'm gonna be displaying this, else I'm gonna be printing out the error, else console dot write line is equal response dot error message. Okay, so that's gonna be my my API call for the third-party service, and I'm just gonna be calling this method here. Very simple, straight to the point. I'm gonna make it await, and now I'm gonna do .NET build, and this should work perfect. Now I'm gonna do .NET run. Now we can see it's running on port 5190. So let's copy this, go back to my web browser, and inside here I'm just gonna call this, I'm just gonna put slash swagger / index.html. Perfect. And now you can see here I have my service requests and I have my get function. So let's try it out. Let me zoom in to see how this is looking. Okay, let me zoom in more. Perfect. So let's click try it out and execute. and basically we got a 200. And now if I go back to my console, we can see that the results were null and there wasn't anything. I wonder why. Sometimes this API just fails for any random reason. I'm not really sure why it does that, but let's try this again. So I'm just gonna update this. Oh, I'll just utilize random here, and let's stop this application and let's run this again. And let me go back here and execute. Again, we got a 200, and now we can see it's actually working. And I got a response back which says that all of this mumbo jumbo, and all we got here is the value. The world is supposed to end by 2012. Chuck Norris must be retiring. So this is like one of the lame jokes that we can actually get, but we can see here that the API is actually running and we are actually able to get the information that we need. Okay, great. So now that we have made sure that the application is running, let's see what happens if I turn off my internet connection. And this will simulate basically that the unavailability of a third-party API. So here, for example, I have my own API and I'm calling another API. So what happens if the internet connection, or for any reason this third party is unavailable? And right now what we're gonna be trying to mimic, if I'm gonna turn off the Wi-Fi of my laptop and I'm gonna connect, and we're gonna be seeing here that that's gonna fail and I'm gonna get an error message. And this gonna represent like, for example, a service which is unavailable, any connection error, any network error, so on and so forth, unauthorized connections, etc. And here we can see how we can actually see the real world scenarios of when this could happen and how we can actually mitigate this by implementing the retry policy. So inside here, all I'm gonna be doing is just turn off my Wi-Fi, and now I'm offline basically. And if I execute this, although it says it gets a 200, let's go back and see we can see here that the error is basically something is not valid, and we're getting that the API is not available for us. So we can see there's nothing matching our server and it's not actually being able to pass. So let me connect again to my Wi-Fi. And now it's connecting. And now if I go back and execute this, and if I go back here and scroll down, you can see that I got my lame joke back, which Chuck Norris Eclipse plugin made an alien contact. So that's basically it. So now, like, for example, I know here that my API is basically failing. This needs to be adjusted a bit because it's not really successful if I'm getting this failed message here. So what we can do is we can say that, let me try one more thing to just try this out. So I'm just gonna put here console.writeLine response.error message, and let's see this. So again, I'm gonna turn off my Wi-Fi and I'm gonna try to do this calls again, and here this should fail. And let's see what we have here. Oh, it's not running even in the first place. So let's run this. And let's go back here and execute this. And if we get here, we're also getting this same error, node name or server is not provided or not known. Okay, so that's the error, and we can see here failed. No, this is not it. So this is the error that we're currently having. And let me just say, put something like this, error, and I'm gonna put plus. Again, let's stop and run again. It's running, execute, and this is the error. So what we can do is, other than the server being failing or trying to utilize the server response is successful, because if we print this out, let's see what do we get. Console.writeLine, I say error status, and I'm just gonna add here the response dot is successful, and let's see what are we gonna get if we do this. If it says true, it means that this API request is not really working as it should be, but let's try it out. So let's come back here and let's execute this. And we can see here that it's false, and basically we're able to get this. So is this exactly what we want? And the reason we are always getting a 200 here, because whatever is the response is, we're returning an OK. So that's why we're getting a 200. But this means that our logic is working as it should. So let me remove these. Perfect. And now we know that our application is not working, so let me connect this again. We're connected. I go back here, I execute. Oh, I need to run this application. I execute the request. We got a 200 and we got our lame joke. Perfect. So now this is working. The next step is we're going to be implementing a retry policy in case once we disconnect our internet connection to try to mimic a server not available. We're going to implement this retry policy, so it will run basically 5 times and it will wait every single amount of time for 30 seconds, for example. We're not going to wait 30 seconds, we'll make it shorter, but this is the example. And then we're going to be seeing how this will work. And basically whenever we connect back the internet, or basically the service becomes available again, it will basically resume the operation as it should be. So let me stop this. So before we do this implementation, I would like to go to the web browser, and I'm just gonna go to, nope, I wanna go, not this Google. Reject all as always. And I'm just gonna put here dotnet poly retry, for example, and I want to go to the actual library, and here we can see that we are on the new, GitHub page for this library. And if we scroll a bit down, we can see here all the different functionalities that we can actually implement within this library. As well, if we scroll down, we can see the different implementation that we can actually utilize within this library. And it's a really valuable document that I highly suggest you go read and actually go through and try to experiment. But for this, in order for us to make this video simple and it will not take a long time, we're gonna go through the different, the few of these different implementation, which is gonna be the retry and the circuit breaker. If you're interested in anything more, please let me know in the description down below. I'm gonna post this link in the description. So now that we just showed you this, let's go back to Visual Studio Code and let's implement the retry policy here. So what I'm gonna be doing is I'm gonna provide a policy. And basically what a policy means here is I'm gonna be adding some rules and regulations for my API, and basically these rules is gonna set like how many times I wanna retry, what's the waiting time that I need to utilize, and all of that. And for this I'm gonna be utilizing poly, which allows me to actually add these rules and policies that I want. So first of all, I'm just gonna put var. I'm gonna say this is gonna be the retry policy. I'm gonna say it's equal to policy. And the, oops, not poly, policy, okay. And this is gonna require me to add a new fixes references. Okay, perfect. And then here I'm just gonna say dot handle, and here it's gonna telling it that whenever you have an exception, so we can for this reason I'm just gonna make it as generic as possible, or for the simplicity of this video I'm gonna make it as simple as possible. Basically any type of exception that's being thrown around, Poly will be able to catch it and implement this policy on. But we can actually go much more deeper and basically have a much more specific policies for any different type of exception. So if it's an HTTP exception, if it's gonna be a serialization exception, if it's gonna be a connection exception, so on and so forth, we can actually implement different retry policy based on every single type of exception that we might think of. But in order for us to make this video simple and not to make it very long, we're just going to be making a general exception, and here we're going to be utilizing the normal exception rather than a much more specific one. So here I'm just going to implement the retry. So I'm going to say retry, and then I'm going to be utilizing the fourth one. I'm going to input the number of retries and the action that it needs to take. So here I'm just going to say it's going to be 5 times retry, and on retry, so this is the action, I'm just going to pass to it the exception and the retry count, and then we're going to be utilizing this anonymous function. And all I'm going to be saying here that console.writeLine, and I'm gonna say here that the, let's say, error, for example, it's gonna be exception.message, and also I'm gonna specify the number of retries. So again, here I'm just gonna say put retry count, and I'm just gonna put the retry count. So that's the policy, and basically it's a very simple policy. I'm just saying for any random exception that you might find, please do a retry 5 times, and this retry, every time we retry, just post the message that you are finding, and then show the number of retries. So because this is going to be quite fast, I think 5 should be enough. And then once we have done that, now we need to actually execute this policy, and the way we do that, we're going to put await retry policy dot execute async. Is it execute? Yeah, it was execute because we did not make it retry async. And here all I'm gonna pass is basically let's make this without await because we did not make it async. And here all I'm gonna be doing is just call whatever method that I want, and in this case it's gonna be the this connect to API. So let's just take this. Okay, I think because this is await, let's make this a better async. Await. Okay, and let's change this to retry async. Okay. And I'm just gonna comment this. Oh, it's already commented. Okay, so let's just let me .NET build. Okay, now it's building .NET run. So the first task we're gonna be doing is I'm just gonna run the application normally, and we should be able to basically get the response that we want. So if I go back here, and we can see that everything is working, and basically we were able to get the response that we need. So let me go back right now. I'm gonna disconnect from the internet again, and then I'm gonna run this. Okay, so before we retry, I just remembered something that we need to add, and basically what we need to add here is we need to actually throw an exception. So what we're doing, if in case not successful, I'm just gonna throw an exception here. I'm just gonna put throw new exception. I'm just gonna pass a message not able to connect to the service. And the reason I'm throwing an exception here, because what we did within our policy is it needs to handle an exception, and if I'm just handling it gracefully as I am here, I'm not able to respond to anything, basically, because we said there's multiple types that I can handle. It could be a connection exception, it could be service unavailable, HTTP, and to make it as simple as possible, I'm just throwing this exception here. But for example, I can have like a switch statement on different types of errors and throw those types of exception and let my policy to be able to pick it up. But for now, I'm just making it generic as possible. So right now, what I'm gonna be doing is I'm just gonna run my application. So .NET run. Again, I'm still not connected to the internet, and all I'm gonna be doing is execute. And basically here, if I come and be able to see that the amount of execution that happened, so we can see that my error is like basically 1, 2, 3, 4, and 5. So basically it connected 5 times before it actually crashed and gave me the error that it's not be able to work. So we can see here that my actual API actually tried to do a 5-time retry to my connection to my service. It's very fast. So this is not really the most optimal way we can actually utilize retry. A better way that we can actually utilize is just call it and basically wait a certain amount of time and then try to call it again, and then wait a certain amount of time and then call it again, so on and so forth. So always trying to do a retry directly is not really always the policy. It might work for certain services, but for example, in this case, it did not work. So what we're going to be doing is I'm just going to add a retry and wait, and that will gonna be actually give us a bit of a buffer. So we'll just make it like 10-15 seconds, and we'll be able to retry again. And what I'm gonna be doing is once it reaches the 3rd retry, I'm gonna reconnect to the internet, and basically we're gonna see how it's gonna actually be able to pull the information that I needed from my service. So let's change my policy. So I'm gonna stop this first, and I'm gonna go back up to my policies here, and I'm just gonna create a new policy. I'm gonna call it var retry wait policy equal policy, as we did before. Again, it's going to handle any types of exception that I have, similar to what we have done previously. And then I'm going to put retry, wait and retry async. This is the one that I want. And if I take a look at the implementation that are available for me, we can see that I can specify the retry count, and I can specify here as well the sleep duration that I needed. So that could be one. Another one, it could be an action as well. So the retry count, and then a function where I can specify the sleep duration and then the action that I want to take. Let's see what other is available. Then we can see here different implementation for the on retry async, so logic that needs to go whenever I'm implementing on retry. Here we can see that it's a much more simpler one within a sleep duration as well as on retry, so on and so forth. And there's a lot of different ones. So let's first connect back to the internet, because before we do that, I would like to just make sure that my application is actually running as it should be. So I'm just gonna comment this out, and I'm just gonna put .NET build, actually .NET run, and let's go back to my application. I'm just gonna click on execute. I should have a 200, and if I go back, I'm able to see my lame joke. Okay, perfect. So now let me uncomment this and let's continue with it. So first thing, I need to specify the amount of retries. I'm just gonna make it 5 again. And the amount of pause that I want here, I can utilize a time span, and I'm gonna say it from seconds. And I'm just gonna make it 10 seconds, let's say 15 seconds. And then what I want to do is I want to specify the action that I want to take on retry. So what I can do is I can put on retry, and I can specify the exception. And what else should I put? And I can put here the time span, which should be the retry count. And here I think, let's see why is it cannot convert them to system func. Oh, okay, so let's fix this by making it much more generic. So I can put var amount to pause equal, let's take this out, and I can just make it like this, I amount to pause. Okay, so here what I'm gonna do is quite simple. All I'm gonna be saying is console, similar to what we have done before, .write line, and I'm just gonna say error. I'm gonna just post a message plus exception.message, and then I'm gonna say the retry count, similar to what we're doing before, nothing really out of the ordinary. Retry count, and I'm just gonna post the message here. Sorry, the count here. So it's gonna be, oops, retry count. Okay. Again, it's gonna be the similar implementation. So first things first, let me just comment this out so we don't execute both of them. And I'm just gonna take this here, and here what I'm just gonna be doing is just utilizing it. So I'm gonna put await retry policy, retry wait policy dot execute async, and I'm just gonna pass here async and just call, similar to what we have done before, the await, sorry, the connect to API, await connect to API, And now let's see what happens. So right now I'm gonna dotnet run. Application is running. Go back to my browser, execute, got the 200, got the lame joke. Now let's disconnect from the internet. Let's come back here, execute. And if we take a look here, we can see that error not able to connect to the service. And then I'm having the 15-second wait. So let's wait, give it a bit more time. We can see it did not give me directly another failure. So now we can see it's connecting again. It's waiting 15 times, doing another connection. It failed, it's gonna connect again. Now let's give it another shot. Failed again. But now what happened if I connect back to the internet? So let's do this. It's connected back to Wi-Fi, and now whenever it does another retry, I should be able to get a lame joke again from my API. And we can see here that I actually was able to get, because that retry policy was able to work. And although I have given a bit of time to wait, as soon as my service back went back up, it ran exactly as it should be, and I was able to get the information that I need. And here we can see the benefit of having to wait, do a retry and wait, rather than just keeping retrying without any buffer and waiting. Because basically if a service is down and we keep on retrying, we're basically hammering those services in order to get that information, and we're not going to be get really anywhere. But if we wait, give the service the time to basically restart, or basically if it's a failure there, by the time it restarts and basically initialize all of the services and it's able to accept a new incoming request, it will be very good for me to just wait and enter for that service to be running, so I get my response that I needed. And that's why here it's very beneficial for us to actually have the break as actually waiting and then basically retrying again. So now that we have experimented with the retry and the wait and retry, the last one we're going to be experimenting today is the circuit breaker. So let's see how we can implement that. So what I'm going to be doing is I'm going to just stop this, and what we can do is, let me just comment this out. Actually, let's leave this amount, we're gonna be needing it. And let's add a new policy. So first things first is I need to create a policy. So it's gonna be a retry policy, a retry and wait. So I'm gonna put var retry policy. It's gonna be equal to policy as we did always. And then here I'm going to specify the handle, which is going to be what type of it. I'm going to say exception. And then I'm going to put wait and retry async. Actually, let's without the async for now, so we can try different ones. And here all I'm going to say is the number of maximum amount of times is going to be 5 times. And I'm just going to say we're going to utilize the same time span that we have initialized previously, so amount to pause. And then I'm going to specify the on retry let's just say exception, and I'm just gonna say retry count, and it's gonna be the same error as always, or same message as always. So let's copy paste it. And why is this not happy? Oh, sorry, I forgot this. Okay, so now that we have created my retry policy, it's pretty straightforward to what we have done before. We're waiting, and for every time it fails, we're just doing something else. Okay, so now I'm going to implement a circuit breaker. And if you don't know what a circuit breaker, don't worry, I'm going to delve into details about the 3 states: open, closed, and half open. After we write this circuit breaker code, we're going to go and actually explain what do they mean. So var, now let's put the circuit breaker, so circuit breaker policy equal policy. Then I'm gonna put dot circuit breaker. Actually, we forgot the handle exception, and then I'm gonna put here dot circuit breaker. I'm gonna specify how much do I want to retry this. I'm just gonna say it's 3 times. And I'm gonna put timestamp, time span, dot from seconds, 30 seconds. And what I'm gonna be doing right now is I'm gonna combine the retry policy and the circuit breaker. Again, we're gonna be explaining what these are. So I'm gonna put var final policy equal retry policy dot wrap the circuit breaker policy. So basically I'm combining both of them. I'm combining the retry and the circuit breaker into one policy. And lastly, I'm gonna put policy, final policy actually, dot execute and here, oops, what I'm gonna be doing is console dot write line. I'm gonna say executing. I'm gonna call my method, which is gonna be the await connect the API. Let's try to make this as synchronous so we can see that this also works on synchronous. So I'm just gonna copy this all of it. I'm just gonna make this a synchronous request. And I'm just gonna remove this. I'm gonna make it void. And here, instead of making it an async, I'm just gonna make it execute and remove the await. Okay, so now I just can take this normal sync request. Okay, and now this should work. And let's try this out. Oh, actually, before we do that, let's go to my web browser. And I'm just gonna go to Google again. I'm just gonna put poly circuit breaker because they have a really nice illustration about it. And we can explain it through there instead of us trying to redefine everything. Closed, where is it? Okay, this is the nice illustrator. Okay, so we all know, okay, let's make it this bigger, let's see how it looks. We can see that it looks actually good. Okay, so we all know that let's say take the electricity current so we currently have at home. So what happened when we turn on the light is basically we flip the switch, and basically the circuit is now closed because basically it's all connected in a circle, and now the lights turned on. And that's mean that whenever we want to turn on something, we're basically closing the circuit. And when it comes to retrying, it's the same concept. And for example, when we turn off the light, we're basically opening the circuit up, which means that there is no direct connection of electricity, so the electricity will stop turning on the light bulbs, and because the circuit is now open. So in summary, when we're closing a circuit, will mean that we have a full circle, and basically the electricity is working as it should be. In our case, basically our application is running as it should be. On the other hand, when the circuit is open, it means that there is no full circuit. There is like a emptiness, or basically there's no connection between the full circuit, and that's when like we have to stop executing whatever we're executing because there is no continuous connection there. And similarly, when it comes to retrying, so whenever the application is running as it should be, or the retries are working as it should be, it's closed. But once we reach a certain amount of time and it actually fails, so basically that will happen is a circuit is being broken, and then when it's actually it converts from closed to open, and once actually converts from closed to open, basically the entire thing stops. And basically from that we'll wait for a certain amount of time, and then what we can do is either we can do like a test run to make sure it's actually running, so that's what we call half open. So we execute a single time. If it actually run as it should within the single time, we reopen, we close the circuit again, and it will continue. If it doesn't, if it fails, we keep the circuit open. So here what we have is within these three circles. So closed means that everything is running as it should be, our application is running, and basically for any types of retry that we currently have, it's actually running as it should be. So in case let's say we retry 5 times and it failed, what happens? The circuit is now open, and it means that nothing will happen, everything is completely stopped, and basically we have to wait for a certain amount of time before we can actually try again and see if it will actually open or not. Actually the service is up or not. So while we are waiting, what we can do is we can do test runs against our service, and this is called half open. And for example, this we are telling, is this open or not open? Is it actually working? So if in case it's working, what we can do, we can change the state of our circuit from open to closed. If it's not, we just close it back to open, and that means that still the service is not available and we have to wait again. And while a circuit is open, we cannot execute any request on that service. Any logic that we have is basically will stop until the circuit is back closed again. So this is a really important thing for us to understand, and the logic behind it. So first it's closed. Once it fails multiple times, it goes to open. Once it's open, we have to wait a certain amount of time before it goes back to closed. And while we are waiting, we can do test runs on those services to make sure they are running again. If they are not running, it will remain open. If they are running, it will be closed, and the circle from there, and it will continue from there. So that's really important, and we can see here the flow of it from close to open, open to half open back to open, and half open back to close, and all depends on the condition if this service is available or not. And I hope this quick explanation was able to illustrate what a circuit breaker is. And basically it means that let's take this in a much more a practical example. So let's say we plugged our laptop into the wall, and basically there was a high surge in electricity. So our plug, which basically contains a circuit breaker, so in case it is failing, or basically there's a high circuit, what it does, it basically breaks the circuit. It will stop it. So it will stop the high level of electricity from coming to our laptop and breaking our laptop. And basically once it does that, it opens the circuit. It means that there is not a closed loop anymore, and basically that means it's stopped. And basically we know that our laptop is not getting electricity, and basically it's being protected, or in this case being protected. In the example for our API here will basically mean that we tried so many times, it's not working, we have to wait until the issue is being resolved, and then we can try again. So you might think to yourself, why don't we implement a retry and wait rather than utilizing a circuit breaker? So these two works in conjunction. So for example, let's say we have a very high and very important application which relies on a lot of different financial services to run. So let's say what we can do, again back to this currency one. So the wait and retry is basically, if let's say we're connecting to a third-party service to get the currency, we retried 5 times, still failing, it will break our application. But with a circuit breaker, is what we can do is whenever it fails, or for example whenever it opens, we can execute a certain logic, is for example to check third-party services if other third-party services other than the one is failing, if it's running. And what we can do is after a certain amount of time, if for example if it keeps on failing, we can switch the service provider from that third-party service which is failing to one which is open. And that's all advanced scenarios that we're not going to be delving into, but that's why some of the reasoning that why do we want to utilize circuit breaker as other than wait and retry. So now that we have this understood, let's go back to our source code and let's run it. And now that our application is running, let me go back to my web browser, and I'm just going to execute this. And here I got my lame joke. But what happens if I turn off my internet and I execute? Basically we got the same error, and if I open it again, we should be able to get my lame joke again after 15 seconds. Perfect. And here we can see that circuit breaker was working. We did not wait enough, and I didn't want to wait 1 minute to make sure it's running to illustrate it, but we can see here that this policy is actually executing correctly and is actually waiting on the running as it should. We can see here that the executing is actually running, making sure that the circuit breaker is actually going through the different loops that we currently have. And basically this is going to be the end of our video for today. We basically went through on the different retry policy that we can actually execute with an API, our API. So let's do a quick summary of that. So first of all, what we did is we created a web API. And then what we did is we connected to a third-party service to get random information from a random API service. And once we were able to confirm that this was working as it should be, what we did is we actually created the retry policy. And the retry policy is basically just, in case it's not working, just hammering that API, a third-party service, just to get the information. And this, as we have seen, that this is not really the optimal scenario, because we need to give it time for that API to come back online and to be able to execute. So this is where wait and retry was able to come into place and be able to help us get there. But again, after a bit of retry, we seen that we can actually utilize something a bit more advanced, which is called a circuit breaker. And we just went through it basically when we have the 3 different states, open, closed, and half open. And basically we saw how we can actually jump from one state to another and what we can do with it. So I hope this video was helpful. Please like, share, and subscribe if you like it. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. And with that said, have a great day, and thank you very much for watching.